All right, we're talking today about surveys and cardinal numbers. We're in section 2-4. So we're going to also talk about something called the cardinal number formula. Get this out of the way. Let's continue on with this. So surveys are sets of problems that involve data from different kinds of people. So the one that we're going to start off with is talking about sports and figuring out information about the survey in terms of what people decided about sports. So here we have a group of 140 people were questioned about the sports that they like to watch. And we came up with this data about football, baseball, and hockey. So what we want to know is, based on that data, how many people like only football and how many people don't like any sports at all. So if we just tried to add up all these numbers, we would end up with numbers that are way greater than 140. So we have to figure out a way to decipher what we have, how much overlap is there, and different things like that. So we're going to do that with Venn diagrams. So we're going to start with the 20 people that like all three sports. And we're going to create a Venn diagram with football, baseball, and hockey as our three rings of the Venn diagram. And the 20 represents the people that like all three of those sports. So now we want to figure out how many people like football, baseball, and hockey based on our two numbers. So there were 40 people that liked football and baseball. So now what we're going to do is we're going to take the 40 people that like football and baseball, and we're going to subtract the 20 people that overlapped in the middle to figure out how many people just liked the football. So we're going to take the 40 and subtract out the number in the middle to figure out that information. So let me grab a pen. So we're going to take the 40 and subtract out the 20 that's in the center, and that's where we got this 20 that represents the number of people that liked football and baseball. Okay, then we're going to take the number of people that liked baseball and hockey to figure out what we have here. So there were 25 people that liked baseball and hockey. I gotta get going. I think my blood sugar's up again. So we're going to take the 25 and we're going to subtract 20 from the middle. So we have 25, and we're going to subtract the 20 in the middle. And that's how we came up with this 5 here that liked baseball and hockey. And then for our last step, we're going to take the number of people that like football and hockey, which is 28, and we're going to take 28 and we're going to subtract the 20 in the middle, and that's how we ended up with the 8 people that like football and hockey. Okay, so then for our next step, to get the 45 and the 25 and the 7, we're going to go to those big numbers that we have, the 93 people that like football. And we're going to sort of repeat our steps here, and we're going to take the 93 people that like football, and we're going to subtract out the 20 in the center, and we're going to subtract out the 20 people that like football and baseball, and we're going to subtract out the 8 people that like football and hockey, and the number that we have left is the number of people that just like football, which is this 45. And then we're going to repeat the same steps with baseball and hockey. So now if we look at all the numbers that we have here, we still don't have 140 people. So that's what we're going to do next, is subtract all of those numbers from 140, and when we do that, we'll end up with the number of people that don't like any of these sports. Oops, let me go back a screen. And so what we find out is that there are 10 people that don't like any of these 3 sports. So now to answer our questions, how many people only like football? So the number of people that only like football are these people over here that are in the football section by themselves. And how many people don't like any sports at all? That's what this 10 number represents down here. They don't like any of these sports that are listed on the screen. And that's our answer to that problem. So then we talk about something called the cardinal number formula. And what this is going to tell us is going to help us to figure out how many people are in these different sets. So if you'll notice here, we have that the cardinal number of A union B is equal to the cardinal number of A plus the cardinal number of B minus the cardinal number of the intersections. So again, if I'm trying to figure out how many people are in the union, then I want to take all of the people that are in A, all of the people that are in B, but I want to subtract out where they overlap because I don't want to count people twice. So that's what we're trying to do here. Now the other thing to think about with this formula is that I can manipulate that formula and change it around. So for example, if I wanted to figure out just the cardinal number of A, I could subtract the cardinal number of B and add the cardinal number of the intersection. So I could end up with the cardinal number of A union B minus the cardinal number of B plus the cardinal number of A intersect B, and I could end up, oops, let's just be an equal sign, with that formula telling me what the cardinal number of A equals. So that's what's going to happen on this next slide, is we're going to take that information and we're going to manipulate that. And so here we have, I want to know what the cardinal number of A is. So we're going to do exactly what we were just talking about. We're going to take the cardinal number of the union and we're going to subtract the cardinal number of B and the cardinal number of the intersection. So the cardinal number of A is going to equal the cardinal number of the union, which is 78, minus the cardinal number of B, which is 36, plus the cardinal number of the intersection, which is 21. And what we end up with is that the cardinal number of A is 63 people. So then we talk about this next set of data, and sometimes it's easier to represent the data in a chart instead of Venn diagrams. Maybe the Venn diagrams get a little bit confusing with a lot of data. So on a given day, breakfast patrons were categorized according to their age and their preferred beverages. And the results were on the next slide. So let me show you what they said. So if somebody was 18 to 25 years old, the 15 of those people preferred coffee, 22 preferred juice, and 18 preferred tea. And there were a total of 55 18 to 25-year-olds interviewed. There were 77 26 to 33-year-olds interviewed, and their preference was more towards the coffee. And then we had 91 over 33 people, over age 33, and their preference was definitely coffee. And then you'll notice at the bottom of the screen, you've also got the total number of coffee preferences, the total number of juice, and the total number of tea. Okay, so then the question is, on the next slide, we're going to look at that, is using this information in the table, and we've abbreviated it a little bit, find the number in each of the following sets. So Y intersect C means where do Y and C meet? What do they have in common? So what we're going to do is we're going to go to the Y column, and we're going to trace it over to the C column, just like a Cartesian coordinate. And where Y and C intersect is 15. Okay, so let's look at this next one. The complement of O means all of the things that are not in O. So all of the things that are not in O would be all of this stuff up here, that whole row and that whole row. Those are the things that are not in O. And then the T values, the things that are in T, are all of these things in this last column here. These are the T values. Okay, so we're looking for the union of those two pieces. We're looking for the union of those two pieces. Let's look at our example. We already talked about this. So let's go with this. The things that are not in O are all of the things in Y and M. Okay? So the 55 and the 77 are the things that are in Y and in M. When I count the things that are in T, I can't count the things that I've already counted. So that's why when we look at this example, we're counting the 24, but we're not counting the 22 and the 18 because I've already counted those when I counted the 55 and the 77. So when I'm looking at what are the things that are in the complement of O and T, when I'm looking for the union of those two things, I'm looking at the 55 plus 77 plus the 24, which is 156. Now another thing that I can do is treat this just like I do with the cardinal formula, and I can do, because this is a union problem, I can do the complement, I can do the cardinal value of the complement plus the cardinal value of T, and then I can subtract out the intersection of those two, which is the 18 and the 22, which is basically what we're doing here. So what I'm saying, if I use the cardinal value rule or formula, I can do the cardinal value of O complement plus the cardinal value of T, and then I can subtract out the cardinal value of the intersection of O complement intersected with T. So the cardinal value of the complement would be 132 things, because I would have to take the 55 and the 77 and add those together. The cardinal value of T is 64, and I got that from right here. The cardinal value of the intersection of those two things would be these two values right here. So I would have to subtract 18 and subtract 22. And you'll notice if you do that math, you'll also get 156. So that's how you can do the same problem using the cardinal value rule. And sometimes it's easier to use the cardinal value rule, and sometimes it might be easier to look at a chart. It depends on the problem. I hope this helps. Just let me know and keep up with your work, and let me know if you have any questions about any of this information.